Okay, welcome once again to this Min-StarkNet build. And today we'll continue from where we stopped yesterday and also talk about how to build an ICO. I think you talked about that yesterday. Okay, Darlington, just take it up from here.
Yeah, all right. Okay, good evening, everyone. Good evening. All right. So we'll just be moving on from where we stopped. That was yesterday. So I think we stopped at I'm just going to share my screen. I'm going to start sharing my screen. All right. So can you guys see my screen?
Yeah.
All right. So I think as of yesterday, right, we stopped at building and deploying an ERC20 contract. So I'm looking forward to us covering we'll be building an NFT contract today. We'll be building the ERC721 contract, and would also be building an NFT marketplace and possibly the AMM contract. So if you are just joining us, maybe today is your first time joining the call, we are using Protostar for this project. So you said as of yesterday, right, that the project was influenced by Miguel's Lilo Web3, and the whole idea is to create minimal implementations of different protocols and standards in Cairo, right, to help you master Cairo syntaxes. So if you are looking to follow up, you could just install Protostar. If you're on Windows, you could check out WSL and clone the repo, and yeah, we can get started. So like I said yesterday, right, the whole idea of the project is not for you to cram codes, right, but for you to understand how, as in what exactly the logic does, and try building it out using Cairo, right? So I also said yesterday, the repo has a develop branch. So the master branch contains the codes, right, the logic, the implementation. But if you're looking to build on your own, then I will encourage you to check out the develop branch. So the develop branch, oh, okay, interesting. Yeah, the develop branch is what contains the interfaces you would probably need to reference to build out your project. So let's just go back to the Min-StarkNet repo and move over to the develop branch. All right, so this is develop branch, right? And yesterday we cloned this branch. And this is what we've been using to this is the branch we've been working on. So I'm just going to head back into, okay, in the chat here. All right. Okay, so I'm just going to head back into my VS Code, my code editor. And we've thus far built out the ENS application, built out the ERC20 token. So we are going to start with the ERC721 contract today. So I believe every single person in the call knows what an ERC721 contract, right? It's the standard for non-fungible tokens on Ethereum, right? So since StarkNet is a layer 2 on Ethereum, most standards that exist in Ethereum also exist on StarkNet. So for the project today, right, we are going to be building it out using OpenZeppelin. So if you don't have OpenZeppelin installed, if you clone the repo, actually, you should have OpenZeppelin installed, because it has already been installed in the lib folder. So if you head over to the lib folder, check out Cairo contracts. Going to the source, you should find the OpenZeppelin contracts. You'll find all available on the Zeppelin's library, right? So for today's project, we are going to be building an NFT contract. So without further ado, let's just get started. So we're going to start by creating a new file, right? We're going to call this ERC721.Cairo. All right. So as always, we said when you are writing a contract on StarkNet, right, you start by declaring a directive. So we'll say percentage long StarkNet. Okay, and we're going to say from Starkware that's Cairo, that's common, that's Cairo built-ins. We're going to be importing the hash built-in. So yesterday we talked about the hash built-in. We said the reason why we import this, right, is because it's going to be used by the Pedersen implicit argument, the Pedersen pointer implicit argument. So we are also going to be importing the unit 256 struct, right? From Starkware.Cairo.common unit 256. We're going to be importing the unit 256 struct. What else would we need? So we probably need okay. I think for now I can't think of any other thing. But yeah, we would also be needing from the Open Zeppelin library, right, which exists in Cairo contracts. Cairo contract inside the library. So Cairo contracts dot let me confirm lib Cairo contracts, yeah, dot source dot open Zeppelin inside the token folder. Inside those token source open Zeppelin. Inside the token folder, we have the ERC 721 contracts. So we are going to just go into that folder and then also go into the library file. And from there, we are going to be importing the ERC 721 namespace. Yeah, we're going to be importing the ERC 721 namespace. All right, let me just close this so I have more space. So now this chat. Is Open Zeppelin already working on Cairo 1.0 contract? Well, I don't think so. Open Zeppelin is not yet available for Cairo 1.0 contracts because currently, at the moment, Cairo 1.0 is not very readily available. So there's pieces here and there, but it can't even be deployed to StarkNet. So currently, we can't find the Open Zeppelin library hasn't been migrated to Cairo 1.0 yet, and I don't think there's any contract on like any project existing on StarkNet currently that has fully migrated to Cairo 1.0 yet. But most persons are spending their time learning Cairo 1.0 currently, preparing for Regenesis. So okay, we are going to also be importing. We're going to be needing the all right, from also the Cairo contracts, right? The source that's Open Zeppelin. We want to we're going to import the Enable library. So if you head over to access, head over to Enable in the library.cairo, there's the Enable namespace, which can be easily imported and used for access controls. So we are going to be importing that. That's from access, Open Zeppelin, there's access. So in access, we are going to be going to Enable, and we are going to be Enable, sorry. We also need to go into the library file. And from there, we are going to be importing the Enable namespace. So we can just do this, right? So to get started, right, like I said earlier, while we were working with our ERC20 contract yesterday, right, because we were using Open Zeppelin's library, there was no need to probably set sorry, let me move this over here. So there was no need to set or create storage variables since all this has already been done behind the scenes. All this has been abstracted by the Open Zeppelin's library, right? You just need to import and import the namespace and use every available available function in the namespace. So we are going to start 721 token. We are going to do that using the constraints, use the external keyword to create this, and I'm going to change the constructor. So we talked about decorator yesterday, right? We said decorators are the way we inform the compiler of what exactly that function is, whether a constructor, a storage variable, a getter function, as a view function, and etc. Yeah, so we are going to call this the constructor. And in the constructor is going to take name, the symbol, name, the symbol, and we would probably the name, the symbol. I don't think we'll be needing an owner currently. We could just use the name and the symbol. Also, I also forgot, we need to check for there will need to be a check to ensure that our NFT token subscribes to the standard interface, right? So for that, we need to import from OpenZeppelin's library, right? So we are going to be importing the ERC165 library namespace. So we're going to head over back. I think that should be in introspection. So yeah, in introspection / ERC dot introspection dot ERC165. We're going to be importing the ERC165 namespace, right? And would know further what that does as we go forward. So we're simply going to head over to initializing a new ERC721 token by calling the initializer function of the OpenZeppelin library. And once we do that, we're going to be passing the name and symbol, since that's what our function accepts, right? The name and the symbol. So we are just going to return this, right? Like we said earlier, every function in Cairo ends with a return statement. So we are going to be implementing every single function contained in this interface. So if you fork or you clone the develop branch, right, you would find out that every single implementation, unlike the master branch, in the master branch, you have just the logic. But if you head over to Min-StarkNet, right? If you head over to the develop branch, which sorry, a minute. Hey, very sorry about that, guys. I had a call coming, so I just had to put my phone into all this stuff. Yeah, so if you head over to the develop branch, right, just like I said earlier, every single project that was created has an accompanying interface. So the whole idea is to you could look at the interface and try implementing the function logic yourself. So same way we have access to the NFT token, that's the ERC721 interface, right? We are going to be looking at this and we are going to try implementing the functions ourselves. Sorry, yeah, so we are going to be looking at the interface and we are going to try implementing the functions ourselves, the logic. So the first function we have here, let's just go, these are the getter functions. Let's call these getters like the view functions, right? The first getter function we have, we're just going to put the external keyword to bring out is the first getter function we have is the name function, right? So the name function takes in no arguments. but it takes in no argument, but it returns the name, name of the NFT, right? All right. So we're just simply going to return. We imported the we imported the ERC721. This is not correct. The correct thing should be ERC721, right? Yeah, the correct namespace is ERC721. So we imported the ERC721 namespace earlier. And like I said earlier, importing the namespace gives us access to every single function contained in the namespace, right? So we're just simply going to return, we're going to return, we're going to return ERC721 dot read, ERC721 the name. That's to get the name of the NFT. Then we are also going to, we're just going to copy this, right? And duplicate it, since the symbol is just typically the same thing. So we're going to name this to symbol. And this also we're going to rename to symbol. And once we return the symbol of the ERC721 token, then we are going to need to implement the balance of. So the balance of function checks the balance of a particular account. So we are going to just, this takes in, it takes in an argument owner, and it returns a balance which is of type unit 256. So we're just going to query for the balance of, balance of, and all right, this is supposed to be balance of, right? And we are going to be querying for the balance of that particular owner, the argument which was supplied. And we are going to be moving on to the next view function. So safe transfer from is an external function. Transfer from is an external function. Approve is an external function. Set approval for all is an external function. So, but we want to finish up with our view functions first. So we are going to go over to the get approved function. So we're just going to paste once again, then rename this to get approved, right? Let's call this get approved. Now get approved takes in a token ID. It takes in a token ID and returns of type 256 and returns the approved status. Okay, then we also have the is approved for all. This is going to be get approved. Get approved, and this takes in the token ID. Yep, the token ID. So having done that, we are going to be implementing our next and our last getter function, right? That's the is approved for all. So we are just going to be changing this to is approved for all. And we are going to be returning, okay, this takes in an owner and an operator. So it takes in owner of type fields and an operator also of type fields, and it returns the is approved status, right? So it returns is approved, which is also of type fields. We are simply going to call the is approved for all, right? And we're going to pass in the owner and the spender, arguments. Right. So once we have done just that, we are going to, I think we are done with our getter functions. So we are simply going to just move over to implementing our external functions. So I'm just going to market it using this and call this externals. All right. So Our external, in case you are new to Cairo, right? I don't know, you can't differentiate between a getter function, a view function, external function, right? A view function is a function basically that you query and it returns, probably returns it returns a state, right? So when a view function can only like return the state of the blockchain, but does not have the capacity to write or modify the state of the blockchain, while an external function modifies or writes to the state of the blockchain, right? So, for example, when you are using your agent X, you can probably make read queries without paying for gas fees or going through an account object, right? But if you're going to make write calls, if you're going to make calls to an external function, you would have to probably pay for gas fees. You would probably have to involve an account object. So we are going to be implementing let's start from the transfer from function here. So we're just going to call external decorator. Yeah, and we're going to call this transfer from. Yeah, transfer from. All right. So the transfer from function, it takes the from argument, which is of type failed. It's two arguments. Let me just it's two arguments also, which is of type failed. The token ID, which is of type UA256. Okay, yeah, if from E2 and a token ID. And so we are just simply going to call the we're going to call the ERC721 namespace, and inside the ERC721 namespace, we want to call the transfer from function. We're going to call the transfer from function. And we are going to be passing in these arguments. We're going to be passing in the from, the to, and the token ID. All right, so once we are done, we're just simply going to return. All right, okay. So the next external function we are going to be implementing, right, is we're going to be implementing the safe transfer from function. So we're going to be implementing the safe transfer, right? I can see a question. I mean, it's transfer from function. Means look at the question. Why did we use the failed for token ID? Okay, well, like I told you earlier, these standards come from Ethereum, and just like we discussed yesterday, there have been a lot of arguments as to whether the mixing of failed and UA256 is necessary, right? But finally, Open Zeppelin had to standardize the fact that we have to just stick with the should I say stick with the available standards on Ethereum. So if we want to say we are using the ERC20 standard or we are using the AIM ERC721 standard, right, we have to fully conform to it. And on Ethereum, the token ID is the UA256 variable. So if we are going to implement same on StarkNet, it has to be a UA256 variable. So I don't know if that answers your question. Okay, it's approved for all. Let me check that. It's approved for all. Okay, Una no Prito. Sorry, I don't get a question. You're good. Okay, Una no Prito. Sorry about that. Yeah, I get that. Una no Prito. Thanks for that. Yeah. And we are simply going to move over to the balance of two. Well, looks like I made a lot of mistakes. Balance of, I think it takes the owner. Yeah, 721 dot balance of. Sorry, can you probably unmute your mic? I don't get that. Una.
Yeah, I was thinking from the interface, it is balance off. But when you wanted to call it from the ENA stack and namespace, you wrote balance underscore off. That's line 33.
All right. So basically this, okay, this is also if I get a question right, if I get a question right, this is also an issue we had earlier. So on StarkNet, we normally stick with the camel case, right? I think the the snake case. So on Ethereum, I think the standard is usually the camel case, right? But on StarkNet, we normally use the snake case. But just like what I said earlier, if we are going to stick with the standards on Ethereum, then we have to do it completely. And that's why the parts that is getting exposed, right? For example, when you use the Open Zeppelin library, all the stuff inside here is not what gets exposed to the user, is what you've written here that gets exposed to the user. Is this contract the user is going to be interacting with? So the parts that get exposed to the user has to totally subscribe to like the available interface on Ethereum, and that requires using the camel keys rather than the snake keys. I don't know if that answers your question. So also this does not in any way like affect this or correlate with this. We are calling this function. This function is more like, let's say, an internal function we have access to. This is not exposed, right? This is not external function. So we are just calling this function, but this particular function that we create is the one our user gets to interact with. I don't know if that's your question, or legal is that your question? Does that answer it?
Yeah, thank you, Avispa.
Okay. Yeah, you're welcome. All right. So we are simply going to head over to the safe transfer from so the safe transfer from, it takes in firstly it takes in the from argument, which is of type felt. It takes in the two arguments, which is of type felt. It takes in the token ID, which is of type UNIT 250. Of type UNIT 256. We take in the takes in data length, which is of type fields, and we can also supply a data array, which is type fields. Well, okay, so over here we are just going to call the namespace. Inside the namespace we are calling the safe transfer from, yeah. We're going to be passing in these arguments, right? The from, the token ID, the data length, and then data. Yeah. So once we do that, we are just simply going to return. All right. So the next external function we need to implement is the approve, right? The approved function. So we are simply going to create an external function here, which is called approve. Yeah. So the approve function takes in an approved and a token ID, right? So we're just going to call this approved, which is of type fields, and a token ID, which is of type UNIT 256. Token ID, which is of type UNIT 256, right? Yeah. And we are going to call right, the approve function of the concept in this library. And we're going to pass in those arguments. So the address we are approving, and the ID. All right, and we are also going to return once we are done. Okay. So the next external function we are going to be calling is going to be the next external function is the set approval for all. So the set approval for all, And this function takes in an operator, which is of type field, and a token ID. And token ID, which is of type int 256. So we are simply just also going to just call the set approval for all. The set approval. What am I writing? The set approval for all, and we're going to pass in the operator and the token ID, right? Set approval for all operator. Oh, this is a mistake. Set approval for takes in an operator and an approved operator and unapproved, which is also type field. Right. So set approval for all operator and approved. Okay. And we are simply also going to return. Okay. And having done that, the last function we are going to implement is a min function. Now, this min function is not part of the interface. It's not like a very necessary thing, like it's not part of the standard. I mean, it's not something must necessarily implement. So, but the whole idea is, okay, if you want to be able to mint new NFTs to probably different addresses, right? There's a need for an external function to do that. And that's what the means function is going to do. The means function. Now, this means function is just going to take in an address, right? An address of type field. That's the address you want to mint to. Now we're going to do something. Before we want to mint, right? We want to implement a check that the address we are minting, sorry, that the address, the person or the caller trying to mint that token is the owner of the contract. Now, to do that, we need to set an owner for this contract. So we're going to just head back to our constructor, right, and set an owner. So we're going to do that by calling the ownable library. And inside the ownable library, we're going to call the initializer function. And we are going to be initializing the owner as in the owner variable, the owner argument, sorry, as the owner, right? So if you head over to the ownable library, let's just check that. So you probably follow up. So if you check the ownable library.cairo, you can see there's an initializer function and there's an assert only owner function. So the initializer function is used to initialize the owner, and we can use this to guard to check if the person trying to mint our tokens or mint a new NFT, right, is an owner. So we are just going to head back into our back to our contract, right, our means function. And in our means function, we want to check first. Okay, to use the get caller address, right, we need to import common import the get. Yep, sorry about that. My network decided to disconnect me. Back now. Can you guys hear me?
Yeah, I can hear you now. Yeah.
All right. I don't know where I lost you guys. Was it when I was trying to like add import the get caller address library? Yes, okay. So what I just did was I imported the get caller address library from the Cairo Lang library. So it gives us the right to use this get caller address. And basically what this get caller address does, right, is when we call it, it returns the address of whosoever is calling the function. So we are now going to check, and to do that, we're just going to apply a check, right? Okay. You need to do that. We're just going to say we're going to use the ownable namespace we created earlier or imported earlier, this ownable namespace, and we are going to call. Let's just do something I'm not supposed to do. All right, so and we are going to call the assert only owner function. So we're just going to come back here and I'm going to call assert only owner. Sorry, was it only owner or only token? I think it was only owner. Assert only owner. Let me show. So if you head back to ownable library.cairo, right? Just check that. So is assert only owner? Yeah, that's correct. So assert ownable.assert only owner, and we want to check if the caller is an owner. All right. So once we do that, the next thing we want to do now is to mint a new token or mint a new NFT, right, to the supplied address. But to do that, we need to generate, should I say, we need to generate a new token ID, right? Now we don't have a means to keep track of our token IDs, like the tokens in our NFT park. We don't have a means to keep track of the IDs. So we're just going to come over here and we're going to create a storage variable. And we're going to call this token counter. And this token counter is going to just simply store the ID of the last, okay, it's going to keep count of, this token counter is going to keep count of the total NFTs minted by storing the ID of the last NFT that was minted. So currently we have 0 NFTs minted. If it means 1, this ID is going to increase to 1, and just like that, it's going to keep count of all the NFTs minted, right? That's the previous ID. So to make things a little more fun, we could decide to emit an event. We could decide to emit an event each time an NFT is minted. So we could say, let's emit an event. Let's call this token minted, right? And we are just going to emit an address, right? The address that was minted to the token ID, which is 256. And yeah, once we do that, we are good to go. So we're just going to go back down. And first of all, we want to query for the current ID. Let's call this the current ID. And we're just going to call token counter. Yeah, token counter. We're going to read from it. So it should return the ID of like okay, let's just call this, rather than current, right? Let's call this the previous ID. So once we do that, it's going to return the previous ID of the previous NFT that was minted, right? And after we get in that, right, we want to see, let our current ID, that the new ID now should be equal to the previous ID. The previous ID plus 1. All right. So once we do all that, we now have an address to mint to and a token ID. So if we go to the ERC721 library, let's look for the mint function. Let's look for, there should be a mint function. So, all right, let me just use my finder. Mint, let's look for that. Let's see it means. Let's just look using this normal means function. So if you check the means function, it takes in E2. The 2 is the address, and a token ID of unit 256. So if it needs a token ID of unit 256, it mean that we need to convert our ID from a field, because it's currently a field value. Remember, we are storing field values as token counter. We're storing field values in here. So we are going to convert this field value, the field value of our current ID, to a unit 256. So we're just simply going to call the we're going to call the main function, right, in the ERC721 namespace, and we're going to supply the address we want to min2, all right. And the next thing we're going to do is we're going to change, we're going to, using the min256 struct, we're going to change our current ID to unit256. Yeah, and once we are done minting, we want to change the value of the previous token counter to the current ID. We're just going to say token counter right, and we are going to be writing the current ID. We're going to be modifying it to the current ID, and having done that, we're just simply going to return. All right, so we now have our min function completed, and I think our NFT contract is ready to go. Okay, yeah, we said we want to emit an event, right? So once we have done all these, right, we want to simply just say token what she just right. Let me check, go back there. Token minted, okay. So we just want to call want to emit the event token minted dot emit, and we're going to be emitting the current ID, sorry, the address first and the current ID, so the address and the current ID. That's the idea of the minted NFT. Yep. So having done all that, I think we got our ERC721.Cairo contract completed. So we're just going to save this contract. Yep, we're going to save this contract, and yeah, I am sure we implemented everything in here. So then we're going to head over to our protostar file. We're going to head over to our protostar.toml file, and we're going to just uncomment the ERC721 line here. And we are going to try building our protostar our ERC721 contract. So I don't think I have this in yet. So I'm just going to just going to head over to this. Okay. I'm sorry, StarkNet Africa. Okay, Min-StarkNet. Yeah, let's copy this guy to the terminal. Yep. Yep. Nice. All right. All right. Well, I'm just going to run the protostar build command to build our contracts. So we talked about the protostar build command yesterday. We said that's how we compile our StarkNet contracts, right? So if everything goes well, we should build. If there's an error, we should return the error. So there's an error here. So it says, oh, right. Yep, I forgot my closing bracket. I'm just going to head back in and back to our min function. So this should have the closing bracket here. And we're going to save and try building again. All right. It seems we still have more errors here. So it says we can't find the module. It seems our import path is wrong. So let's go back and check that. Yeah, I think we missed one more thing. First of all, let's correct our path. So we're just going to head back into, okay, source open Zeppelin. And yep, inside here, we're going to introspection. And this part is introspection.erc165. All right, yeah, the library, we missed that. So we're supposed to head into our library. And we missed a single getter function, and that's the function that checks for the function we can use to check for correspondence to a standard interface, right? So let's just use external to get that out, and let's change it to view. So this particular function checks for interface support. So we're going to call this support interface here. And this should just take in your interface ID. Yeah, it should take in your interface ID. Should be of type fields. And then we are simply just going to, if you head into the library.cairo, the ERC-165 contracts, right, you can see the ERC-165 namespace implements a support interface function, and this takes in an interface ID. So we are simply just going to go back to our contract, and we're going to make a call to that function that supports interface, supports interface. All right, and this takes in the interface ID. All right, so we are just going to return this. We're going to return this at once. And I think this completes our contract. So let's go back and try building once again. All right, we have an error. Cannot convert. Oh, right. So this is a return statement. It's supposed to return. So what exactly does it return again? I think the status, but let me confirm. So head over to the library.cairo once again, and the returns, yeah, the sources failed. So we're just going to return, okay, not this. So the wrong place to do this, right? So over here, we are going to just return sources. Yeah, failed. All right, now let's try building again. Still have another error apparently, so cannot reconvert the return type. We still missed that again. 61, line 61. Well, return ERC 721 dot is approved for all owner and operator, and we got this right. So what might be missing? All right, let's just do this. Let's just say let is approved for all. Be equal to this, right? I'm just going to, okay, let's call this is approved instead. This is the Lord. Let's approved for is equal to ERC 721 dot is approved for. Let me confirm that. ERC dot is approved for all. Just find that. Is approved for all. Is approved for all. So we're just going to go back. Yeah, the function is approved for all. It takes it and returns the is approved. All right. So we're just going to come over here and return is approved. All right. So let's break it that works. Okay, so we are back here. Expected exactly 0 expressions got 1. Oh, interesting. The assert only owner doesn't take in an argument. Sorry about that. That's been a while since I did this stuff. Okay. Right. So expected expression of type. Once again, I still made, so we're just going to simply copy this, right? And we're going to paste this here. And now let's try building once again. Yeah, so we've completed our ERC 721 contract. As you can see here, it has been successfully built. So with ProtoStar, right, I said earlier, each time you build your contracts, if you head over to the build file, you should find your ERC 721 API. The API is what you probably use if you are looking to call this, probably call the functions contained in this contract from a front end. This is going to be very helpful. Then we have the ERC721.json. This is the particular contains what we are going to be deploying, right? So we're just going to head over to this, right? So now, so return is approved is equals to is approved. It's same as return. Yeah, exactly same. It's the same thing basically. So most times the return statements are tuples. So use this to actually specify what exactly you're returning, or you could use this to say, okay, I'm only returning the first value. So they are basically the same thing. So now we're going to head over to declaring and deploying our contracts. And like I said earlier, so declare and deploy contract to the update to 2.10.3, the deploy syscall was deprecated. So if you are going to declare or deploy your contracts, you need to do that from a wallet. And as such, we need to set the private key for the wallet we'll be paying gas fees for. So I said to do that, you can run the command export protostar, right? Protostar account private key, private key, and in here you would paste your private key equal to, and you paste your private key. So just like we did yesterday, for the purpose of security and privacy, I'm just going to stop sharing for a minute, and I'm going to set my protostar, my agent X. So to get a private key, for people who were not here yesterday, just if you haven't installed agent X, because agent X is the browser extension, the wallet extension we are using, just head over to Chrome Web Store. Head over to Chrome Web Store for Agent X. You could find it here. All right. Sorry, my network is a little bit slower today. Okay. Yeah. So head over to the web store and just click on Add to Chrome, set up your agent's wallet, and you'll be good to go. So I'm just going to open my agent wallet, and to get your private key, simply go here, export private key, and you can actually just set a private key that way, carry it, copy it, and come paste it in the terminal here. So I'm going to stop sharing my screen for a minute, and I'm going to set my private key, and then we're going to go ahead to deploy, declare and deploy our contracts. So okay guys, give me like a minute or so. So I'm just going to do this. All right, copy, password. All right. Okay, so I'm going to paste that in my terminal. Enter, then clear. Right. So I'm going to start sharing my screen back once again. I'm going to start sharing my screen now. Right. Yep. Okay, can you guys see my screen now? I just need to confirm. I'm not getting any responses. Okay.
Yes, I can see your screen.
All right, thanks. Okay, so now we are going to head over to deploying our ERC721 contract. And just like we did yesterday, we need to declare first. So we are going to run the declare command. We're going to run the declare command. I'm supposed to declare. We're going to specify the path to our ERC721 contract that we are about to declare. And we're going to pass in the account address of the private key we actually used. So my account address is this, right? So I'm just going to copy that, and I'm going to paste it here, and I'm going to pass in okay, any other thing? Yeah, I'm going to pass in the max fee. Sorry, I'm going to pass in the max fee, which I'm just going to specify as auto, and I'm going to lastly specify the network I want to deploy to, and that's testnet. All right, so I'm just going to hit the declare command. If everything goes well, we should have our contracts declared on testnet. Okay, it's taking a little while. All right, so we can see our contract has been declared. So we can just use this take it out and go check it out on StackScan. So StackScan, like I said yesterday, is an explorer for StarkNet. So think Etherscan for StarkNet. So when we head over to that class hash, we can see class does not exist. So our contract hasn't been declared yet. So we have to wait a while, because if our class hash is our contract is not declared, then we'll be deploying a class hash that doesn't exist on the network. So we'll have to wait for our contract to be declared first. Right, this is taking more time than I expected. Let me check out the transactions to be sure it never didn't fail because of probably gas fees or something. Let's move over here. Yeah, let's check this out. All right, I suspected same. So it says fee transfer failure, actual fee exceeded max fee. Well, all right, so you know what I'm going to do? I'm going to try declaring it one more time. If it doesn't work out, probably just set the max fee manually myself. All right, so I will just try it out once again. If it doesn't work out, manually sets the max fee value. All right, I'll wait for that, right? Once we are done with our ER721 contract, once we've declared, deployed, and interacted with it, we are going to head over to the next thing in our list, and that's an NFT marketplace. We are going to be building. All right, let me check if this has been declared yet. Yeah, so let me check the class hash first. All right, check the class hash. Okay, so just head over here and search for the class hash. Does it exist? No results found yet. So let me just confirm the transaction didn't fail once again. All right, so I'm just going to head over here and search for that transaction. Okay. All right, so it has been received. All right, spend is still, it hasn't gotten to the pending state yet, and it's not even near being accepted on L2. It looks like the testnet network is a bit slower today. It's a bit slower today. So because of time, we are just going to proceed to the NFT market contract. So I'll wait for this to go through. That's going to pending. Now, this is one of like the advantages of using StackScan presents over most explorers existing on StarkNet. Okay, it's accepted on L2 now. So let's go back to search for the class hash. So this is the class hash, right? So we're just going to copy that, and we're going to search for that. And we should have it somewhere. Yeah. So this is a class hash. The class hash has been successfully declared. So we are just going to head over to deploying our contracts now. To do that, we're going to run the command protestar deploy, and our class hash, we're going to paste that. All right. So we are going to specify the inputs to our our contract. So our constructor takes in a name, a symbol. All right, this, I made this mistake again. So this and this should have the field data type. Is always good practice you specify data type. Although the constructor might pass such mistakes once, generally safer you do this. So okay, so we need to, all right, we need to specify the name, the symbol, and the owner, right? So I'm just going to head over to the tool we used yesterday. That's this utils.tubufish.co. And for the name, we're going to just use StarkNet Africa. So we can copy this and pass that in as an input. That's our first input. Second input is our symbol. So for our symbol, let's just use Stark. Let's just Stark. Let's just copy this. and paste that as a symbol. And for our owner, I'm just going to use my account address for the owner. And yeah, so having done that, having specified our inputs, we're going to go ahead to specify the account will be declaring from the account address of the I will be deploying from, and that's still my account too. Then we are going to be specifying the network, which is testnet. And lastly, we're going to be specifying the max fee, the max deployment fee we want to pay, which is auto. And we are going to try declaring our contracts. All right, sorry about that. I have to disconnect my external display, and I'm just going to share my screen once again. All right, so we just someone's in the chat. Okay, so we just deployed our contracts now. We deployed our contracts. So the contracts should probably have not been deployed yet, because I noticed testnet is a little slower today. So we're just going to copy this transaction hash and just track our transaction ourselves. So I'm just going to head over here and I'm going to, all right. Sorry about that. Let me get the right. Let's just copy this. Okay, so I'm going to head over here, paste this here, and try searching for this, right? So from here we should be able to, okay, as always, I don't know why this is happening a lot today. So my transaction was rejected once again with the excuse of fee transfer failure. So I'm just going to try to deploy it once again, and hopefully it doesn't get rejected. Sorry, give me a minute. All right, so I'm just going to check out this on StackScan once again to see if he had same issues. So I'm going to, all right, sorry. All right, this is going now. So it says transaction is pending, right? Yep, well, probably I'll do that next time. Yeah, all right, so okay, so it has been accepted on L2. So since it has been accepted on L2, we can see our contract address here. So let's just visit that. And when we go to the read contracts, we should be able to read, yeah, all right, this is wrong. This is right. Yep, this is our contract address. So let's just search for that. So so if you check for the name, right, you should get back StarkNet Africa. You check for the symbol, you should get back Stark. All right, so the first thing we're going to try doing, right, is we're going to try minting. We're going to make an external call, and we're going to try minting a token. Probably I'm going to mint to my own account, so I'm just going to copy this, right? And I'm going to go to Mint. To do that, you need to connect to your wallet first. So you can connect to Agent X or to Bravos, but I have Agent X installed here. So I'm just going to click on Agent X, and I'm going to paste in the address. So this is the address I want to mint to. I'm going to try minting. Yep, so I'm going to just approve this transaction, and we are going to wait for a while to see if our token was successfully minted. And if it does, we'll just go here and check for the balance of this, the balance of my account to see if any token was minted Yeah, so while we do that, just give me a minute. All right, we still haven't, okay, our transaction just went through now. So we are just going to check for the balance. All right, that's a mistake. We're just going to check for the balance of my account, and we should say probably tokens. So I'm just going to put this here, and I'm going to query. So as you can see here, our balance has increased to 1. So why do I think we are actually missing a function? Let me confirm. Yep, we actually missed a function from our earlier implementation. I thought about it. The owner function is not here. So well, you could probably implement that when you are building yours. I forgot that actually. So but let's just head over to the next contract. So the next contract we are going to be looking at is okay. My network is really slow today. At least it's better than yesterday. All right, so okay, we just built this ERC721 token, right? Next up, we are going to head over to building an NFT marketplace. So we've just built a token, right? So what if you had this NFT you were looking to sell, right? You would probably want to like sell it in what we call a marketplace. So marketplace is a place where sellers could probably advertise their NFT tokens, put it out for sale, and buyers could come buy the NFT token. So as you can see from here, we see it implements 2 external functions. We are going to be looking at this as we go forward. So we're just going to head back into our, all right, we're going to head back into our code editor, and we are going to be opening the NFT marketplace. We're going to create a new file. We're going to call this NFT market.cairo. All right, NFT market.cairo. And before we go forward to build this out, right, I want us to take out time to understand what exactly the NFT, as in the contract we are building, what exactly does it do? Because just like I have repeated since yesterday, the whole idea of the repo is not to get you to cram codes, but to understand the logic and try building it out yourself. So for the meanwhile, I'm just going to close all this. I'm just going to move this in. So, all right. So yeah, let me move this, open this in here. Okay, and I'm going to just minimize this and open the master repo, which contains the logic. Now let's head over to the NFT marketplace. And in there, we're going to go into the NFT markets.cairo. All right. So I'm going to keep this side by side. Let's minimize this, right? And I'm going to keep this side by side. Okay. So while this is side by side, we're going to try understand these contracts. At the same time, I'm going to write some guides that will guide us on how we'll probably implement these contracts. So the first thing we need to note is, okay, we have, we first declared our directive, our language directive, then we went ahead to import some certain libraries we are going to be using. We also imported from OpenZeppelin, okay, from previous things we've built, right? We imported the ERC721 stand interface and the ERC20 interface. So as you can see from here, the first thing we had to do was we had to create a struct, right? We had to create a struct. So this struct, we had to create a struct listing, right? And this listing is going to contain a token contract. It's going to contain a token contract, a token ID, a seller, and the price of the token. Now, structs are a way to create custom data types. If you come from a Solidity background, you understand what exactly the role of structs are in contracts, right? So it's a means by which we can create a custom data type. Then next thing we do is we created a constant, right? We created a constant it contract, and that was where we pasted our it contract. So we're going to be interacting with the it contracts because when you are if you are using Solidity, for example, you have access to the payable keyword. So if you want to pay for, let's say, something using the it token, right, you could easily add the payable keyword to your function. But on StarkNet, you don't have access to the payable keyword, as the Ethereum on StarkNet is a token. So would learn to use to interact using contract interface, to interact with other contracts using StarkNet interface. Using a contract interface, sorry. So we're just going to set the Ethereum contract address on StarkNet as a constant. Then we are going to head over to create some storage variables. So I'm just going to call the storage variables. Okay, I'm going to go ahead to create some storage variables, which we'll be using our contracts. So the first of them is we're going to be creating a storage variable all listing. Now, this storage variable is going to map IDs. It's going to create a mapping of an ID to a token. So basically, the whole idea is you could actually access any listing available on this NFT marketplace using the ID. And if you make a call to the all listing, you should be able to like return that particular token for the ID you supplied. Then we are going to create another storage variable. That's the listing sales status, right? The listing sales status. Now, this particular storage variable, right, it keeps a count of the status of every token listed on the NFT marketplace. So if an NFT listed on our marketplace has been sold, we want to be able to query for the status of that contract to know if it has been sold or not, right? So this just maps a token ID to like the sales status. So let's just call this the sales status, right? Then we are going to create a third storage variable, which is called listing counter. Now, listing counter keeps a count of all NFTs available on our marketplace. So we are just going to, this is going to just keep a count of all NFTs. So if you make a call to it, it should be able to return the ID for the last NFT that was listed on our marketplace. And yeah, so we are going to also emit certain events. We're going to be emitting certain events. So we're going to be emitting an event when a listing is created. We're going to be emitting an event when a listing is created. And that event is going to be broadcasting the token which was just listed. We're going to also be creating an event, so that's going to broadcast the buyer and the token. Then we are going to head over to our getter function. So in our getter functions, we have, I think, 3 getter functions. So we have get listing. Get listing, we have access to the interface already. If you check INFT marketplace, so it's Cairo, we have access to the get listing interface. But when we look into the logic, right, we want to understand what exactly does this function do. So what it does basically is it makes a query to this all listing variable, and it returns. So we can see the get listing function, right? The get listing function returns the token when it takes for the supplied address, for the supplied ID, right? It returns the token for the supplied ID. Then we also have the next view function, right? The get sales status. So what exactly this function is expected to do, right, is it returns like the sales status for the supplied ID. So if you put in an ID, right, it returns the sales status for that supplied ID. Then we have our third getter function, right, which is get total listings. I think that is very descriptive. It simply just returns the number of listings we have, right? The number of NFT listings we have. Now, if you are wondering how we keep track of it, right? If you check this, we had a storage variable earlier. Yeah, the listing counter. So basically, all this listing counter does is currently with no token listed, the listing counter is 0, right? So if you haven't heard this before, right, when you create a storage variable on StarkNet, it is automatically initialized to 0. So each time we create an NFT or we list an NFT on the platform, by doing that, we'll be able to keep track of every listing, like keep track of the number of listings we have on our platform using the listing counter storage variable. So having done that, the last part we have is the external functions. So the external functions, as you can see, we have the list token external function. We have the list token external function. Now, what exactly does this function do? So as you can see here, we get the caller address, then we create a listing struct. So we're going to be creating a listing struct for that particular listing we want to make. Having created the listing struct, we're going to transfer the listed token ownership to this contract. So the seller is going to be transferring ownership. We're going to transfer ownership, right, of the listed token. Well, let's just say transfer token ownership, right, to ownership to this contract. We're going to transfer token ownership to this contract. Then we are going to need to update the available listing. So we get the previous index, and then we move over to increase it by 1, and then we update the all listings, update the available listing. After updating the available listing, the last thing we're going to do is we're going to update the listing counter. We're going to update the listing counter. And finally, we are going to emit the listing events, the created events. Let's just call it the created events, right? We're going to emit the event at creation. Then we also have a second external function here. Now, this external function is called buy token, right? The buy token external function. Now, this sets different sets. We're going to first of all set some variables we are going to be needing, like the buyer, this contract, listing price, token ID, and the rest, right? So, but there are some important things we need to keep note of, right? We are going to need to check. We're going to need to check that the listing first of all exists. We're going to check the listing exists. That's the first thing we need to check, right? Then the second thing we need to check is that the listing is not yet sold. We want to check that the listing is not yet sold. Then something we can also check for, even if you don't, as in necessary, doesn't like alter the state of our contract, right? We can check that the user beforehand approved like the address of the contract address of the NFT market contract to spend the listing price from its edge balance. But we're just going to skip that since this 622, and I want us to go through some more contracts, particularly the AMM contracts. We're just going to skip that. It's not like super necessary. So the next thing we want to do is we're going to accept it from buyer. We're going to accept it from buyer. We're going to accept it from buyer. Then we are going to transfer the accepted it to the seller. We're going to transfer the accepted it to the seller. Then transfer the token to the buyer. And finally, we are going to emit the listing sold events. We're going to emit the listing sold events. So this, what we just did here now is we just built a simple NFT marketplace. So basically we create a listing, just to go through it again, we create a listing. A user, to create a listing, a seller would have to call the list token function, right? And to buy the listing, a user has to call the buy token function. So someone has a question. The screen is not moving again. Oh, serious. Can you see my screen now? Is it? I think I had network issues. How about now? Okay. Can you guys hear me?
Yeah.
Yes, I can.
How about my screen? Can you see it?
Yeah, you can see
Yes, I
it.
can see it.
All right. So we are running out of time, so let's just head over and just try building and deploying this contract. So we are going to let's just okay. So I'm just going to open this to the side, right? Let's just open this to the right because we're going to be referencing it while we build, and we're going to be creating. I think we created one already, an NFT market.cairo. All right, so we're going to start building. Firstly, we're going to start with our directive percentage lang StarkNet. Then we're going to be importing the necessary stuffs from Starkware. We're going to be importing Cairo built-ins. All right, we're going to be importing the hash built-in. Right, we're going to also be importing from Starkware.cairo, all right, so it's cairo.common. We need to be importing, sorry, not capital letters, .uint256. We're going to import the uint256. We're probably going to also need the uint256, I think non-negative, less than equals. Let me confirm that. All right, let's just check out. Okay. Okay, signs non-negative less than equal to. So if you want to check out these stuff, right, just head over to the Cairo Lang library by Starkware. I'm just going to paste this in all right, so just head over here. This is the source folder. Okay, I'm just going to paste this in the chart. All right. So head over there, check out the source for StarkNet related commands. You check Starkware. So from StarkNet related commands, you actually system call commands, right? You have to check StarkNet. And for Cairo related commands, we're going to go into Cairo. Now check out the common folder. And if we go into math.cairo, right? We are looking for a function we could use to check that it's both non-negative and is less than or equal to. So I'm just going to find that function. Assert non-negative. Yeah, so this is the function we just imported. So the assert non-negative less than equal to. We would also be needing from Starkware, .StarkNet actually the system call .common .syscalls. We're going to be importing the get caller address, and the get contract address, and the get contract address. We're going to be using those two. So basically the get caller address is used for getting the person who is making calls to the function. The get contract address is used to get like the address of the contract itself. And we're also going to import some stuff from, okay, we don't need OpenZeppelin actually. We already have these interfaces available. So if you go into the ERC721 folder, right, from source.min ERC721, right? If you go into the ERC721 file, that's this, you should be able to import the ERC721 namespace. We are going to be needing it. So we are also going to be importing from the min ERC20.IERC20. We're going to be importing the ERC20 file. Now, if you've not been exposed to interfaces before, interfaces are going to be very helpful in this particular contract we're building. So basically, how do I explain it for the interface now? Okay, I would say interfaces are a means by which we can specify like a function, or what do you call it again, a function signature, right, without particularly specifying the logic contained inside. And they are actually very helpful when you want to interact with other contracts available on the network too. So for example, if you go into the ERC721.cairo file, you can see that we have the function signatures. By function signatures, I mean the function body, right? You can see the function bodies have been like abstracted without, but the logic inside is, there's no logic inside, right? So using this, we can actually interact with other contracts on the network by supplying the particular contract address if we want to interact with it. So when we get there, I would explain that better. So basically, our NFT contract does not have a constructor, so there's no need for that. So we're just going to go ahead to, first of all, create our struct. And like we said, let me check that again, right? Head over back here. We could see that our struct is going to, let me close this. So our struct contains a token contract, which is going to be of type field. It contains a token ID, which is going to be of type UN256. It contains a seller, which is also of type field, seller address, and the price of the token, which is going to be of type field. All right. So this is how we create structs in in Cairo. So the next thing we're going to do is we're going to get and store the edge contract address. We're going to just say edge contract address, right? And we are going to store that. For that, I'm just going to go copy that from the repo. Okay, where you can actually get that is just head over to StackScan, go into developers, check the address book, and you would see address for very important contracts on StackNet, like the core contracts, StackNet's core contracts. In case you are interacting with the messaging bridge, you can see the StackNet core contract, the GPS statement verifier. Then you can see the core accounts address, the core account contracts for agents and bravos. That's the two major wallets on StackNet. Then we need the Ether contracts, right? So we're just going to copy this, and we're going to head into our code editor. We are going to paste that. Having done that, we are going to move element, right? Is the all listing variable. So the all listing variable. So this all listing, it takes in okay, the all listing takes in an ID, right? And it's a mapping, so you don't take in, it's a mapping of an ID to a token, an ID of field. Now this token is going to be of type listing. That's a struct we created earlier. So if you were listening attentively, I said earlier that structs are a way to create custom data types. So they are very helpful in when writing smart contracts. So we are going to create a token of type listing. So, and yeah, so the all list is a mapping of ID to token. We are also going to create another storage variable. I'm just going to raise this. I'm going to create another storage variable. This is going to be called listing sales status, right? Listing sales status. And the listing sales status takes in is a mapping of an ID, the listing ID to its status. So I'm just going to call the status, and it returns the status for whether it's sold or not, right? And the last storage variable we have here is the listing counter. So the listing counter takes in, okay, don't take in anything, it just returns the previous ID. That's the last ID for the last listing that was created, right? So we also have events. For the first event we have, right, we called that listing created, and that's going to emit a token which is also of type listing. All right, and we're going to emit another event, sorry, and this event is called listing sold, and it returns the ID, and all right, the ID and the status. This is not supposed to be the status. This is actually supposed to be the token. Sorry, not this. All right, I was copying the wrong thing. Sorry, the listing sold returns the buyer. The person who bought the contract, and the token which was sold. All right. Okay. So having done that, we are going to head over to our getter function. So we're just going to call these getters. And the first getter function we have here, so I'm just going to use this to bring out, and I'm going to use to view. The first getter function we have here is the get listing. Right, I can see charts like question. Is the interface we are going to be working with the interface, all right? We're going to be working with two interfaces. We're going to be working with the interface for the NFT, an NFT, that's an ERC721 token, and we're going to be working with an interface for an ERC20 token, that's the ETH address. So like I said earlier, Ethereum on StarkNet is an ERC20 token. So we are going to be working with both interfaces, and you will see how we'll use them as we go forward. So, all right, I don't know if that answers the question, CC. Okay, so while we wait for his answer, let's just move on. Okay, so the get listing returns the token. Okay. Yeah, you're welcome. All right, so the get listing, like say, returns the token for the supplied ID, right? So if we check the interface, what does the get listing take in? It takes in a listing ID. It takes in a listing ID of type field, and it returns the listing, that's a struct, it returns a listing. So we are just going to come here and we're going to see, this is a simple way to do this. We're going to return from all listing, right? We're going to read the one for this particular listing ID, and we're going to return it at once. This is better a way to do it in one line. An alternative, you could also do something like, right, so nobody gets confused. This was what we used in the last contract, but we could also do something like let listing be equal to all listing, the read all listing, the read listing ID. All right, listing ID, and it just, they both work the same thing, but we're just going to keep things cleaner and simpler by using it in one line. All right, we're going to also do same thing for the next getter function, that's the get sales status, right? So this is a view function, not an external function. So I'm going to just change this to get sales status, and the get sales status takes in a listing ID also of type fields, and it returns the status. All right, the status field. So basically, we're just going to say return listing sales status dot read. All right, listing sales status dot read for that particular ID, that listing ID. Yep. And we're going to head over to the third one, the third function. I'm going to head over to the third function. So the third function, getter function we're implementing is the listing counter, right? So the listing, I'm very sorry for the background noise. I currently am raising my Bluetooth, so a lot of the noise might get into the call, and I apologize for that. So okay, so the listing counter, we're just going to that should take in a listing ID, right? The list, oh, that's not the listing counter, but on the get total listing, I got distracted for a moment. The get total listing, and that basically does not take in anything, but it returns the total listings, right? Total listings, which is of type fields. So we're just simply going to return the value of the listing counter, the current value of the listing counter, the read. We're just going to return that. All right, so this is also a view function, not an external function. So we are going to head over to our external functions. That's where the work is. We're just going to head over to there. We're going to just head over there now. And the first external function we are going to be implementing is the list token function. So just right, the list token function. So we're going to call the list token. We're going to call this the list token. And the list token takes in a token ID, which is of type uint 256. All right, sorry. It takes in a token contract address first. A token contract address of type fields. A token ID of type uint 256. And a price of type fields. Right. Yeah. So having done that, the first thing we are going to do now, let me check our instructions right. Said for the list token, we want to create a listing struct, but for that we'll be needing the address of the seller. The seller is most likely the person calling the contract, is definitely the person calling the contract. So we are going to use the function, the list token function, right? So we're going to use the get call address to get the address of whosoever is calling the list token function. Then we're going to create our listing struct by using a listing, and we're going to be supplying the token contract address. So our struct takes in a token contract, a token ID, a seller, and a price. So we're just going to take this a token contract. All right, the token ID, right? Yeah, the token contract, the token ID. The seller is going to be the caller. Rather, just to make it better, let's call this the seller. Yeah, the seller. And lastly, we're going to take in the price. All right. So that's, we just created our listing. Now, having created our listing, right? The next thing we need to do is transfer token ownership to this contract. So to do that, first of all, we need to get the address of this contract. We're going to need to get the contract address. So we're going to do that using the get contract address system call. And once we get the contract address, we are going to head over to now this is how we use an interface, right? We're going to call the namespace, the interface area 721, and we want to use the transfer from function. All right. So we are using the transfer from function here because in a transfer from, right, you would need to approve the person. You need to approve the person who the spender. So in this case, we have the owner of the tokens, we have the spender of the tokens, right, and the recipient. So the transfer from function enables you to approve another person to spend the tokens contained in your wallet, right? So we need to use the transfer from function in this case because when we are making calls to this function contained in the contract address, what the network probably sees as the caller is the contract address itself. So we need to approve the contract address to spend tokens from our wallet in order for the transfer function to get carried out. That's the reason why we are using the transfer from function, because we can't use the transfer directly. So to use an interface, right, the first thing you would need to supply is a token contract address. That's the address of the contracts you want to be calling the interface function, right? The interface, like I said earlier, it just gives us the function signatures, but the logic contained within is abstracted away. So having gotten the function signature, right, the function name, we can now be able to call specific functions contained in that contract without necessarily having the full contract with us or having the logic available to us. So that's why each time you are using an interface, right, in both Solidity and in Cairo, the first argument you must always supply, right, is the token, the contract address you want to be interacting with, as in using the interface to interact with. So in this case, the contract address we want to be interacting with is the token contract address of our NFT contracts. Now we deployed an NFT contract earlier. Don't tell me I removed that. Okay, let's just go back. Yeah, this should be it, right? So we're going to be using that. We're going to be really needing that. So we're just going to keep it handy. All right. So let's just go back to what we're working. The network is a little bit slow. Yeah. So this is our NFT contract we deployed earlier. So we are going to be calling the transfer from function on this NFT contract. And we are going to be passing in, all right, if you check the interface, right, transfer from takes in a from, a to, and a token ID. So the from is going to be the caller, as the person calling the list token function. We've gotten that earlier as this, we use that as the seller. All right, just in order to prevent the revoked references error, right, we are just going to get any reference error. So if you understand how probably if you've joined some of our previous classes earlier, we talked about revoked references, how if you specify a variable using the lets, it's a temporary variable, and if there are other stuff happening in between, the reference can get revoked before you probably call it. So we're just going to use the alloc locales to prevent that. So having done that, we are going to, the receiver is going to be this contract, right? We're transferring the NFT we want to sell to this contract. And lastly, we want to, I think that lastly, the token ID, right? So we're going to be supplying the token ID. All right, so having done that, we should be able to use that to transfer our NFT from our wallet to this contract. Then I think the next thing we would need to do, right, is to update the listing, right? So let's just check that. So it says we need to update the available listing before updating the listing counter. So to update the available listing, we'll simply just call the all listings. So before that, we need to create a new listing ID, right? But to do that, we need to first of all get our previous listing ID. So we're just going to say let previous ID, right? Let previous ID be equal to, is that the listing counter, right? Yeah, the listing counter. We're going to read the value of the listing counter to read. And having gotten that, we are going to say let's new ID be equal to previous ID plus 1. And lastly, we are going to update our listing. So we're going to say all listings are right. We use right to modify the storage variable, right? So we're going to say all listings that's right, and we're going to be supplying the new ID and the listing, the new ID and the listing. All right, so I think there's a question here. So please, can you explain the alloc locale again? All right, so okay, we actually ran out of time, but let's run through that. So the alloc locale keyword is something we add in order to like instruct the compiler not to revoke references like our variable references, right? In Cairo, we have what we call temporary variables, and we have local variables. So I think temporary variables are stored in the AP pointer, the other one is stored in the FP. So stuff's stored in using temporary variables, right, are usually revoked after, let's say, certain steps. So let's say we specified the seller here, right? And we probably carried out an operation here, and we want to use that seller variable, maybe somewhere here or somewhere later after carrying out some steps, right? There's a possibility that this temporary variable we specified earlier will be revoked before the point where we'll be using it. So just to test that, let's remove the alloc locales keyword first and see, okay, let's just leave that for now. When we want to compile, we're going to check if our reference is going to be revoked. I just did that as a safety check to ensure that we don't go in and go back. But the whole idea is to prevent your variables from getting revoked. When your variables get revoked, your compiler will throw an error that the variable you are trying to access here has probably been revoked a long time ago. I don't know if that answers your question, you good. For that, let me just throw a resource that is probably very helpful. Let's check cairolang.org/docs. So there's something on revoked references. Let me just search that. Revoked references. All right. Okay, constant references. I think you'll see that here. This explains it's right. Yeah. So this is it. So I'm just going to come here. And I'll just paste this in the chat. You could check this out later because we are running out of time. And probably if you don't understand anything, you could just ask on the group chat, and yeah, I would attend to that. All right, thank you. Okay, so we are just going to move forward. So we just updated our listing, right? We updated our listing, and the last thing we are going to do is we are going to update the listing counter. To do that, we are simply going to call the listing counter. And we're going to write to it the listing counter to write. We are going to be writing the new ID. All right. Then finally, we are going to be emitting the event listing created. So we're going to be emitting listing created, all right, .emit, and what we're going to be emitting is the listing. And once we do that, we can now return. So we have our listing logic completed. So with this, I believe a seller should be able to list tokens on our contracts. And we are going to be trying all this. So the next thing we're going to be doing is we are going to quickly head over to our buy token logic. So I'm going to say at external, call this buy token. Now let's go check the interface once again. So as you can see from here, the buy token implements the listing just the listing, takes in just the listing ID, right? All right. So the listing ID, firstly, we're going to be setting some important things we are going to be using later on. And for here, we are definitely going to be needing the alloc locales keyword to ensure that none of our variables will be revoked when we want to use them, right? So we're just going to start with them getting the buyer, right? So we're going to say let buyer be equal to the get call address. The name of the person getting, as in the name of the person calling the function should be the buyer. Next, we are going to want to probably get the seller. All right, but to get the seller, first of all, we need to get the listing. So let's just get the listing first. To get the listing, we're going to say let listing be equal to all listing, right? Yeah, all listing, and we're going to be reading from the all listing, listing with this particular listing ID, right? And from there, we can all now get most of our stuff. For example, we can get the token contracts, right? We can get the token contracts by querying. Okay, before that, let's get some important stuff. Like let's get the contracts. I just like these two being together, right? So I'm just going to come here and say let this contract, right? The contract, our contract address. We're going to be needing this. We're just going to say let it be equal to get contract address. All right. So where you place it doesn't matter though. I just like it being disarrangements. After the get call address, we should always get the contract address next. All right. So the token contracts, we could get that from the listing.token contracts, right? From the listing structs, we can get the token contract. We can get the seller. Yeah, we could get the seller by querying for listing.seller. And we can get the price, token price, by querying listing.price. And any other logic any other stuff we might need to get while we implement logic. Okay, so the next thing we want to check the listing exists, right? And to do that, we want to throw an error message if it doesn't. Think of requiring solidity. So we want to throw an error if this listing does not exist. So let's say listing NFT markets. We're going to see listing does not exist. All right. So to do that, we want an easy way to do this, right, is to query. Let's say listing exists, right? We want to query that the seller variable is not a zero address. We're going to query that the seller address is not a zero address, as the seller is not a zero address. And we're going to use this is not zero, we would need to be importing it. I can't remember, I think from matcomp, let me confirm. So we're going to go to Cairo lang and go back to common. Let's search for mat. I don't think it's in mat.cairo. So let's mat, it should be in mat compare. So yeah. So let's head over to matcomp.cairo. And inside this file, is less than, is not less than, is in range. Yeah, exactly, is not zero. So this function checks that a value is not zero and returns zero if it's not zero, returns one if it's. So I'm just going to go back in here and I want to assert that zero is equal, sorry, I want to assert that one is equal to listing exists. Now, I said earlier, if you check the code, right, this is basically this method we are importing, right? It checks that a particular value is not equal to 0. So if value is equal to 0, it turns to 0. And if it's not equal to 0, it turns a 1. So if you come here, right, you want to query that the seller is not a 0 address. So if this listing does not exist, right, if you query for listing.seller, automatically this should not exist because the listing will not exist. So if you query for listing.seller, you should listing.seller, right, you should get 0. So now we want to check that listing exists by checking that this address is not 0. And then we want to assert that the value that would get returned is a 1. As you can see here, I want to assert that this value is a 1. Now you notice I had to exchange the positions. Now this is normally advised to be done because, for example, if this listing exists was probably set somewhere else and it was set as 1. If you do something like listing exists is equal to 1, it would, sorry, if this listing exists was probably set somewhere else, right? Doing something like listing exists is equal to 1 is like, I think it should be like assigning, can't remember. Yeah, it's be like assign, okay, the listing exists is equal to is not 0, right? So let's assume we didn't, this should work also in this scenario though. This should work in this scenario since the listing exists already returns a variable which you want to compare, but it's usually better to do it like this instead. It would save you some very big security vulnerabilities. So we are just going to do that. And having checked that, we are going to check that, all right, we're going to, listing is not yet, so we want to check that the listing is not sold, right? So we're just going to also echo an error message if listing is sold, right? So we want to echo NFT market, all right, we want to see listing has been sold, all right, okay. So basically we want to okay, listing has been sold, right? We want to query for, we're going to use this function we created earlier, that's the get sales status. So we are going to just say let status be equal to get sales status, right? Get sales status, is that the name of the function? Yeah, get sales status, and we are going to pass in our listing ID. So get sales status, we are passing our listing ID. All right. So once we get that, we want to assert that 0 is equal to the status. So we want to make sure that the value we get returned is 0. So 0 means it hasn't been sold, 1 means it has been sold. So we want to assert that the value we get back is 0. All right. So having done that, we are just going to close this. And then next up, we are going to accept it from buyer. We're going to accept it from buyer. Now, this is where we're going to be using the IERC20 transfer from also. So we're going to be using the it contract address. What is it contract address? Interesting. Let me show in the list token. Okay, we haven't used that for. Okay, so the it contract address, that's the contract we want to be interacting with, right? Once we call transfer from in this contract address, and the person who is going to be transferring it is the buyer, right? The person calling the contract. So we're just going to call this buyer. So remember, the buyer has been gotten earlier from the get caller address, the buyer. Then we want to transfer from the buyer to this contract first. I want to transfer from the buyer to this contract. All right. So let's transfer. Okay, sorry. Okay, transfer it to the seller. All right. So let's just transfer from the buyer to this contract first. Then having done that, the it we want to transfer is the price, the listing price. But remember that the ERC20 tokens work with UWINs. So we are actually supposed to supply a UWIN 256 variable here. So we're going to change the price to a UWIN 256. All right. Yep. And once we have accepted it from buyer, we just simply want to transfer the accepted it to the seller. Right, we want to transfer the accepted it we just got to the seller, so that should be into 6 of the price. All right, then once we do that, we are trying to buy a token, right? Transfer token to buyer. We actually missed something. So we accept it from buyer, all right. Then we transfer it to seller, and then we are going to transfer the token to the buyer. So to do that, we're going to be using the ERC-721 interface. And all right, so we are going to be transferring. So I said when interacting with your interfaces, right, you should always supply the contract address as the first variable. So we want to transfer that particular token to the buyer, right? The particularly listed token. So we're going to call the transfer from function. I think the IRS-721 does not have a transfer. So we're going to call the transfer from function, supplying the from with one a token ID. So first of all, we're going to supply the token contract. We have that here. I'm going to supply the token contract, which is always supposed to be our first argument. Then we are going to be support the from is this contract. The from is this contract. This contract has access to that token because remember when the seller lists the token, right? He gets it, he transfers the token to our contract address. That's the contract address of the marketplace. So we are just going to transfer that same token from this contract to the buyer. And the token ID, all right, the token ID, have we gotten that? I don't think so. Let's just come here and see let token ID. Let token ID be equal to listing dot token ID, listing dot token ID, yeah. Listing dot token ID. Yep. So we're just going to get that token at 6, so we could just supply that here. Okay, so having from our contract to the buyer, I think we have to do one more thing before emitting the listing sold event. We need to update the sales status for this particular token that we just sold, right? So to do that, we can head over. We're going to alter the listing sales status for that particular token ID. So we're just going to say the listing sales status, right? For that particular listing ID, rather. So we're going to say listing sales status for that particular ID. That's the listing ID. We are going to be updating it to 1 instead of 0. And having done that, we can now emit listings sold with the buyer address and the token ID, right? Listing so takes in the buyer
Hey man, we can't actually hear you again. Network.
the token that was listed, the listing rather. Okay, yeah, and we are going to now return. So I think with this, we just got our
Are you still there?
Yeah, I'm here. I don't know. My network disconnected me once again. I'll just start sharing my
Yeah.
screen.
Okay. It tripped off like a minute ago.
Oh,
Like,
wow.
yeah.
So where exactly did I stop before I just
We are trying to emit. That's when it stops.
okay. So then I just emitted the buy and the listing, and then I returned. So I decided, I said, okay, so having done this right, we should have completed our logic. So the first thing we did right was check that listing does not exist. Sorry, that we want to check that listing existed, right? If not, we want to throw the error, listing does not exist. They want to check that listing has not been sold, right? So we want to check it. If not, we would put out the error, listing has been sold. And then we're going to transfer the price in it for that particular token, right? So we're going to transfer the price in it to this contract. That's from the buyer to this contract. Then we're going to transfer it from this contract to the seller. And we're going to transfer the token from this contract to the buyer. And finally, we are going to update our listing sales status. And finally, we are going to emit the listing sold event. Sure, unmute your mic and ask.
Sorry. So the transfer from that we use on the token ID after it must have been transferred to the contract. I'm kind of confused because when I wanted to transfer the it use dot transfer. When I wanted to transfer the token, he used those transfer from, even though the token is already the
Yeah,
contract. So
I used the transfer from, because if you check our interface, right, the interface, remember we are interacting with our contract using this interface. Our interface does not contain a transfer function. And let me confirm from Open Zeppelin's library if there's actually a transfer from for an ERC 721 contract. If you go into ERC 721, the library.cairo, right, let's just see the transfer function. I'm just going to search for all transfers. So I think there's just a transfer event, but I don't think there's a transfer from, there's a transfer function. The transfer function, there's no exposed transfer function. So that's why we use the transfer from event. That's why we used the transfer from function name rather than just, but this transfer is available on the ERC20 interface. As you can see here, the ERC20 interface has a transfer function, but the ERC721 interface does not. I don't know if that answers your question.
yeah, it does. But the next thing, my next confusion is, won't it need you to approve yourself? Like, do you need to approve yourself? Because anytime I use a transfer from, we have to approve.
Yeah,
So
definitely. So that's the reason for this. That's the reason why this error was added initially, to check that the user should, okay, maybe we should just add it. But basically what it does is that it checks that the user has allowed our contract to spend as much as is needed. So we are going to query for the approved, and we are going to compare and check that it is that. Okay, let's just do that. So to do that, we already have that unit 256. I don't think this is correct. The signed non-negative less than equal to, let me just confirm from the library instead. I think that's okay. Let's just go and confirm from the repositories, though I've done that before. Unit 256 sign non-negative less than equal to, yeah. So we are going to use this to check that one variable is less than or equal to another. So to ensure that a user approves approves our contract to spend from his wallet the listing price, in order to use this transfer form function, right, we can just come here and add an error which is okay. We're just going to come here and see NFT markets. You need to approve the NFT market contract to spend the token price from your wallet. Let's just do that. So the reason for error message is right is to like give the user better feedback as to why his transaction probably failed. So let's just make that detailed, right? So what we're going to do is we're going to query for the allowance that the user, let's say we're going to query using the IRC20.allowance, right? We are going to query its contract, okay, its contract address. I'm going to query that the buyer, in this case here, the buyer has allowed our contract, that's this contract. We're going to check the allowance this buyer has given to this contract. So if the buyer has not approved any token for our contract, right, our NFT market contract, this allowance is going to return is 0. So having done that, we can now say let's less than. Right, let me see how I need to confirm how this guy works. In 256, this math comp. Let's go back to maths. Oh, we are already out of time. We're already out of time. But let's just round up here. So we're going to head over to the maths.cairo, right? And we are going to, okay, let me find out assert, okay? Assert, not this has signed. Well, this does not exist here. Interesting. So where did I import it from? Oh, right, from Unit 256. That's true. We are dealing with Unit 256 variables here. So we're just going to go back here, check the Unit 256 for this guy here. Still does not exist. Okay, Unit 256 sign non-negative. Yeah. Unit 256 signed. Yep. Non-negative. Yep. Less than equal to. Yeah. So this is what we are checking out, right? This is the method we want to use for comparison. And as you can see here, returns result is equals to 0 and returns result is equals to is non-negative. All right. So what we're going to just do is we're going to go back to our contracts, right? And we want to check that Unit 256 signed non-negative less than equal to that our allowance is like less than, sorry, our price, okay, yep, our price of token, which we need to create a Unit 256 variable for, right? Our price of the token, right? I want to check. This is definitely not a very good way to write this because this is definitely not a good way to write this though. Okay, once check that the Unit 256 of the price is less than the allowance. So the whole logic behind this is if this guy has approved, it's less than or equal to, right? So if this guy has approved the price of the token, right, to be spent from his wallet, if you check the allowance should give us something. The allowance, yeah, the price should either be equal to the allowance or less than the allowance. So he's free to allow more than the price, but at least he needs to allow something that is equal to the price in order for this function to, like, this error message to not be thrown, right? All right. So lastly, we're going to assert that less than is equal to 1. All right. So having done all better, still, I'm just going to assert 1 is equal to less than, and these still do similar stuff. So having done all this, I don't know if this answers your question, Leo Good.
Yes, it actually adds to it, but the transfer form we did on the, which line is that? On line 117.
All right. Yeah.
Yeah,
This
we transfer
yeah.
from this contract to this buyer. So I'm saying, like, does the contract need to approve itself? Because
No,
there is a transfer.
the contract doesn't need to approve itself because it is the owner of this token. It's the owner of the token. So it doesn't need to like approve itself to spend its own token. I don't know if you get that.
Okay, yeah, thank you.
Yeah, it does. All right, so we're just going to try building this, but I feel like we'll run into some errors. We'll probably need to sort out first. So just head over to protest.toml. I think we've taken more time than we planned. So I'm just going to just try to debug this, and then we'll probably, all right, the NFT markets. Okay. All right, this name is not correct, right? So we're just going to rename this to NFT market.cairo. And then we're going to try building. I know we are going to run into a lot of errors, but let's see if we can resolve those errors before we go at least. All right, I have no idea why this is taking so much time. All right. Well, it's taking anybody so much time. I think this is easier because I've probably done this before. Well, I'm going to, okay, we missed a semicolon here. So I'm just going to, yep, I'm going to just rerun this, right? All right. It's definitely slower today. Okay, so we still have an error. It says unknown identifier all listings. Well, I suspected this is going to happen. I always confuse that. So we're just going to start on what number? On line 77. Well, 77, this all listing, not all listings. So we're just going to try building again. Oh, Protostar, please don't take so much time. Do have so much time. Right. So while we debug these errors, right, I would have really loved us to touch on the AMM contract today, but that looks like it's not going to be possible. All right. So I think we are pretty done with this, right? I wanted us to touch on the AMM contract at least before going, but time has failed us. Well, it says unknown identifier is not zero. Well, we actually forgot to import the is not zero. So I'm just going to come here from starkware dot Cairo dot common, sorry, dot common dot I think matcom here. I'm going to import is not zero. All right, let's try this one more time. First start, please. There's no more errors. Oh. We can't rush AMM. Well, there's no class tomorrow, unfortunately. But let's see how it's going to be on Sunday. Yeah, let's try. We're going to do AM on Sunday. We're going to do AM on Sunday. All right. So the token ID, it says unknown identifier token ID. Really? Why is it unknown? Okay, 118. Let's debug that too. 118. Token ID is unknown. Yep, it's unknown. This is supposed to be token ID. See the problem of mixing two cases. Always run into all this mess. All right, so let's just go through the I currently at the moment we've touched on the NS contracts, we've touched on the ARS20 contracts, we built the ARS721 contract, and we just built the marketplace. So we still have an AMM and ICO is taking still left, but I really want us to take our time for the messaging bridge and upgradability as the like the toughest concepts in this repo, and they are really a must to understand if you're looking to become a Cairo developer. So I was thinking we're just going to dedicate the whole time to these two on Sunday. But let's just see how things go. I would also love us to touch the AMM contract too. I would love us to touch on that. Well, okay, let me see. There's still more errors. Well, there is. So let's solve this first. Return, convert the return type to the return type of get listing 47. Let's see where we made mistake in 47. 47 listing ID. Interesting. Why do I have that error? Okay, well, the listing is the struct type, right? All right, let's just do this the conventional way. Let's just say let's listing, all right, be equal to this. And we're just going to simply return listing. And this should fix it, right? Yeah, let's try this. All right, so I was saying on Sunday we are going to start from the AMM contracts, but the class is meant to end on Sunday, so we're going to go through the AMM contracts, and we'll probably have to skip the ICO and the staking. The ICO contract is very simple. If you understand how we implemented the NFT marketplace, there's still another error. Okay, that's on 65. All right, seems tough. So we're just going to still do that the conventional way. We're going to see let's total listing be equal to this, and we're going to simply return the total listing. All right. All right, so while we wait for the next error, which will probably pop up again. For Sunday we'll go through the AMM. Should we what do you guys think? Should we start the class on Sunday earlier? Probably do 3 hours instead of 2 hours, because there's a lot to do on Sunday. What do you guys see? Let listing exist is equal is not zero seller. The return type is not a tuple. Interesting. Oh, right. Yep, it's not listing. It is not zero. It's not zero. That's in the error, right? Yep. This is not a tuple, so I think we don't need this. It's not a tuple. Yep. And we are just going to try building this. Shares is cool. How much earlier? Yes, how much earlier? 30 minutes. I was saying an hour earlier. Well, can you extend to Monday? Well, Monday is a little inconvenient for me. I wouldn't be available on Monday. That's why we were looking to any class on Thursday. So finally our NFT contract got built. Well, but what do you guys say? Should we do 3 hours on Sunday? I think in 3 hours we should be able to cover the AMM contract, the messaging bridge, and the upgradable contracts. Would that work? Showers is okay. All right then. Okay, Fox, do you agree to 3 hours? Okay. Kelvin said shower is nice. I've not heard from Leo Gold yet. And okay, yeah. And I don't know who else is on the call. Okay, I think we have Andrew, we have Ephraim, we have Leo Young. So you guys just tell me what you guys think. Well, we just finally got our contract built, but this is 7:22. I would not like to take much of our time. All right, but let's just try. You know what? I have an already deployed NFT marketplace, right? Because declaring and deploying will probably take more time. So we are just going to go ahead. I'm going to copy this NFT market contracts, but this is on testnet too, right? So we're just going to head over testnet to starscan.co, and we're going to try listing the NFT we just created today. We're going to list this NFT and try playing around with it. So first of all, we're going to search for that contract. Yep, this is it. So we are going to go ahead to the right contract. So we are going to connect our wallets. And we're going to try listing this token. We're going to try listing this token that we just deployed earlier, this NFT token. So let's copy the contract address. Heading over here, we're going to need the contract address, the token ID. All right, the token ID, you mean 26. All right, we have the token ID as one, right? Yep, let me confirm though. We head over to these NFT contracts, go out to read contracts. Yep, when we check the balance of the owner, right? I understand. when you check the balance of the owner, we query it. Yep, it returned E1, so let's just use 1 here. Then the price, let's list the price as just use an eta to way converter, way to eta, it converter, eta converter. All right, I'm just going to use something simple, and we are going to use, let's set, all right, our eta to, I'm going to just use 0.01 as our listing price. So we are going to copy it in way, because you can't, the stack scan does not accept decimals, right? So we're just going to use this instead, the way representation, and we are going to try writing. And hopefully it doesn't throw an error. Oh, there's an error here. It says requested contract address is not deployed. Interesting. All right. Well, there's an issue here because our contract was deployed to testnet, and we are trying to interact with testnet, a contract on testnet. So that would definitely not work. That would definitely not work. Well, but guys, I'll just encourage you, check out the contracts, build yours, and try to deploy and interact with it. But here's something I would tell you: do while you are interacting with your contracts, before you call functions like list token, right? List token and buy token, right? Ensure to approve. For example, if you're going to be transferring, for this one, you're going to be transferring an NFT token, right? Make sure to approve the contract address on your NFT token. That's approve the contract address of the marketplace on your NFT token, and also approve the contract of your marketplace on the ETH token while you do this. And yeah, just try it out. It's not something very difficult. Write your own contract, deploy it. And I've used up 25 minutes of your time. I really apologize for that. But yeah, I would be calling it a wrap today. Does anyone have any questions? All right, no questions, I guess. Okay. Okay, yeah, sure, Fox, you could ask yours. Okay, when do I think Cairo 0 will become obsolete? Yep, so that's the whole idea of the Regenesis plan, right? So we'll be switching from Cairo 0 to from the Cairo zeros to like Cairo 1, probably in the next coming months. No one knows, and there's not an ETA yet, but we are looking at probably before the StarkNet sessions coming up by February. Or probably it's going to be after, because I think that's like a few weeks away. So Cairo 1 is still not yet ready, even testnet ready, to talk more of mainnet ready yet. But I think Regenesis is going to take a whole lot of time. The whole idea of Regenesis is to phase out existing Cairo 0 contracts, and to make sure that every single contract complies to like Cairo 1.0, right? So that's the whole idea of Regenesis. And that's one of the reasons why we need to learn upgradable contracts, because for you to like migrate your existing contracts from Cairo 0 points, from the Cairo zeros, right, to Cairo 1.0, right, you must understand how upgradable contracts work. So we're going to be looking at that on Sunday. But well, as for when Cairo 0 will become obsolete, let's say in the next coming months. Okay, Sisi said it would be cool if you did the interaction. All right, then let's just deploy and do that. Or rather than that, since the contracts are same, right, let's just head over to the repo and just interact with both the RC721 and the NFT marketplace already on testnet 2, right? So testnet 2.stackscan.cool. And yep, so let's just interact with them. Let's play around with them, since they are literally the same contract, just on different testnets. So we are going to also open another testnet to the stacks kind of this way would interact with our ERC 721 contract. So I'm going to search for this ERC 721 contracts, which I deployed earlier. This is on testnet 2.2. Now, before I move forward, I want to write contract. So I want to mint a token to myself. I'm not, let me check first for confirm. If let me just try minting to myself, right? And this is the address I want to mint to, and I'm going to try writing. So I'm going to just mint this token. All right, something went wrong. Error, got an exception, error at this, error in the code contract is not deployed. Why do I keep getting these errors? Okay, let me just reload this once again. Right, let's head over to the read contract first. I want to check the balance of this particular account. It has no token. Okay. Okay. All right. Then let me see if I've minted any token previously. Let me try to. Yep, 2 has an owner already. And I guess, all right, sorry, hex 2235. Interesting. Let me try 3. Those 3 have an owner. Oh, 3 does. 4. Those have an owner. Interesting. 5. I think it doesn't. I think it doesn't. Okay. 5 actually does have an owner. Let me try 6. Okay, 6 doesn't have an owner. So let's just try this. 6 doesn't actually exist. So I'm just going to connect to the wallet. All right, I now understand why I've been getting those errors. I just remembered we are on testnet. So we're just going to move to testnet 2. I'm going to be moving to testnet 2. So this is my account on testnet 2, right? I have this account and I have this account, and I think this should be the owner of the account. So we're just going to disconnect and we're going to connect again. Having connected, we're just going to simply go to the mint, and I want to just mint to myself. All right, I'm just going to mint to myself. Let's try this now. Something went wrong. Got an exception. Error in the code contract. Requested contract addresses. I'm still getting this error. Interesting. Anyone knows why I'm getting that error? Because what's different between testnet and testnet 2? Okay, they're basically like just like we have different testnets on Ethereum. We have Gweli. Previously we used to have Gweli, Ringby, Ropstein, Kovan. I think most of it have been deprecated currently. We just have Ringby. We just have I think Gweli. On StackScan, you have testnet 1, you have testnet 2. They're just basically the same thing, but just it means to give developers multi-choice, because sometimes testnet 1 gets to should I say it gets too jam-packed. We have a lot of transactions going on testnet 1, and it might get slow. So developers might have an option to probably interact with. I'm getting errors when trying to interact with this contract, and I'm still trying to place Y. Right, okay. And my network is not even helping matters. Okay, guys, you know what? We're just going to be rounding up here, and probably in the next class, we are going to try interacting with this contract. Let me just try this one more time to be sure. Okay, I'm connected to testnet 2, right? All right, 9.8. Yeah, that makes sense. Okay. I want to mint to this address. So right. Okay. So I think that was an issue with it not discovering my change to testnet 2 earlier. So that was why the contract basically did not exist, because StackScan assumed I was still trying to interact with the contract on testnet 1. So having minted, you see, testnet 2 is super fast today. So having minted our right, we've minted a token, right? So let me just confirm by reading contract. So if I check contract of token 6, probably I should get return my contract. Yeah, perfect. So I'm just going to head over to this guy. Now I want to list this token. I want to list this particular token on our NFT marketplace, right? But before we do that, I'll have to approve this contract address to spend that token. So I'm just going to go over here, go back to write contracts, connect to my wallet, and I'm going to approve all right, the NFT, the token ID 6, that's my token. And once that goes through, I'm going to approve this. And yeah, so that should go in a matter of minutes or a matter of seconds. Once that is completed, right, this is now taking longer time. Well, once that is completed, we can now head over here to our NFT contract. We're going to connect to our wallet and we're going to try listing the token. But before we do that, we have to make sure this has to be approved first. So I'm going to have to wait for this token to this transaction to go through. All right, this is actually slower than even testnet. Well, it's taking so much time. All right, it has finally gone through. So we are simply going to paste the token contract address. This is token contract address. We're going to go over here and get the token address of our contracts, right? Yep. So we're going to go over here and paste our token contract address. Our token ID is 6. And the price we want to use is 0.001. So I'm just going to copy this guy. Come over here on the over here and paste it in. So I'm going to list this token, call this function. And as you can see, we don't run into any errors because we approved our contract earlier to spend from our wallet, to spend our NFT. So having listed the token, which is going to take a while, basically to buy the token, we just need to put in the listing ID. So the question is, we need to get the listing. To get the listing ID, once that is okay, let's just list first. Let's just list first. The listing ID will probably be buying, or the token we'll be buying is the one of the listing that was just recently listed. Yeah, the transaction just went through. So we're just going to call get total listings. And as you can see, there are 6 total listings, right? So we are just going to head over here, connect our wallet. Now to buy the token, nope, I'm going to buy the token using another wallet. So I'm going to head over to account 2, and I'm going to be buying the token using my second account, right? So, but before we do that, as we can see from our codes, right, the buy token, for the buy token, we'll have to approve, okay, as you can see here, we need to transfer it, that's the price of the token in it, right? So to do that, we'd have to go back here and head over to the ETH contract, the official ETH contract on testnet 2. I'm just going to open another testnet2.startscan.co. And I'm going to head over to developer, head over to address book and check out the ETH address. So on the ETH address, I'm going to go to the right contract and I'm going to connect my wallet firstly, then I'm going to approve this particular contract, this contract here, our NFT marketplace. I'm going to approve this guy to, he's going to be my spender, right? I'm going to approve him to spend this amount of tokens, right? I'm just going to approve this amount of tokens to him. Once I call that, once I call the approve function, and this goes through, right? So I'm approving 0.018. So I'm just going to call this approve function. All right. Yeah, so while that is going, once that has gone through, right, I'm going to come back to my marketplace contract, and I'm going to connect to my wallet, and I'm going to try buying the token. The listing ID is 6, right? So I'm just going to wait for this contract, this approve function to go through first. And all right, this is taking so much time. Okay. Up. Well. Once that is gone, we should be able to buy our token successfully for sure. Yeah, that's gone now. So we can just listing ID 6, right? We'll just write to this. And yeah, we'll just approve this. So while we wait for that to go, right, we're going to head back to, okay. Yep, say okay. So we're going to head back to our NFT marketplace contract and our NFT contract, our NFT contract itself, right? So if you check the owner of the contract currently, right, that's token ID 6. If you check the owner, you'll see that the owner is our marketplace. The owner is currently our marketplace. This is the market address of our marketplace. If you check here, you can see that is the address of our marketplace, 2235. But by the time this transaction has gone through, which it has, if we query for this again, our new owner should become our wallet address. That's this. So as you can see, we just successfully listed and bought an NFT. So yeah, so we just completed a successful NFT smart contract. So our advice, just go back, try this out, deploy yours, and play around with it. You could even decide to improve it, add new features. And yeah, we'll just be stopping here for today. We've done quite a lot though. Yeah, thank you so much guys for coming around. If you have any other questions, please just ask it on the group and I will attend to it. So yeah, that'll be it for today. Yeah, see you guys tomorrow. I don't know, Paul, are you there? So not tomorrow, in 2 days actually. Yeah, see you guys in 2 days. Yeah, sure. We just
Okay, thanks, man. We'll get back to it on Monday, the same time on Monday as well.
Sunday,
Okay,
no Monday.
not okay, on Sunday. Sorry, I think we're starting by sorry, I mean that's a mistake. I mean on Sunday, right? We're starting by 4, right?
Yeah, we'll start by phone Sunday. Yeah, 4.
Okay, cool. Yeah, no worries. Thank you for joining. We'll see you on Sunday.
All right, now take care, everyone. Yeah, good night.
Yeah, same.